Converting decimals to fractions. While any ratio of integers can be converted to a decimal, the only types of decimal numbers that can be converted to a fraction are terminating decimals and repeating decimals. A decimal number that does not terminate or repeat is not a rational number and cannot be converted to a fraction. To convert a terminating decimal to a fraction, put the number in the numerator and 1 in the denominator. Then multiply by the power of 10 that will eliminate the decimals. Then simplify. So 0.82, we're going to write that number in decimal form. Put it over a 1. Rewrite it as a fraction with the number in the numerator and 1 in the denominator. Now we're going to multiply, in this case, we're going to multiply top and bottom by 100 so that that decimal moves 2 places to the right and becomes 82 over 100. Then we can simplify. You can divide top and bottom by 2 and you get 41 over 50. Convert 0.725 to a fraction. Alright, so we write 0.725, put it all over 1. Then 0.725, well that goes all the way out to the thousandth spot, so we're going to have to multiply top and bottom by 1,000 to get rid of that decimal. It becomes 725 over 1,000, which can be reduced by dividing top and bottom by 5. You can divide by 5 again to get it to its simplest form, 29 over 40. Converting a repeating decimal to a fraction relies on an understanding that the repetition continues an infinite number of decimal places. That allows for a technique that removes the infinity of repeating decimals and results in a ratio of integers. In the number 0.66666 and so on, the digit 6 repeats infinitely. The following method shows how to rewrite it as a common fraction. First, create an equation by setting the number equal to x. So x equals 0.66666 and so on. Then create a second equation by multiplying both sides by a power of 10 that moves the repeating portion to the left of the decimal. So if we have 10x, then we would multiply the right side by 10 and we get 6.666 and so on. Then subtract the two equations. 10x minus x is 9x. 6.6666 and so on minus 0.6666, well, the whole infinite portion goes away, leaving us with 6. Therefore, divide both sides by 9. X equals 6 over 9. Simplified, x equals 2/3. Write 1.454545 as a fraction. First, create an equation by setting the number equal to x. Then, we create our second equation by multiplying both sides by some power of 10 that will move the repeating portion to the left of the decimal. So because the repeating portion is 2 digits long, we're actually going to have to multiply by 100 this time, so that the repeating portion, the 4/5, moves to the left of the decimal. Then we subtract the two equations, so that the repeating portion goes away, and we just get 100x minus x is 99x, and on the right side, 145 minus 1 is 144. Divide both sides by 99 and simplify, and we get x equals 16 over 11. Write 0.151515 as a fraction. First, create an equation by setting the original number equal to x. Then we're going to create a second equation that moves the repeating portion to the left of the decimal. Because the repeating portion is 2 digits long, we're going to have to multiply both sides by 100 so that this whole 15 moves to the left side. Then we're going to subtract the equations, which gets rid of the repeating portion altogether on the right side. 100x minus x is 99x. 15 minus 0 is just 15. Divide both sides by 99. Simplify, and we get x equals 5/33. Look over your answers for the last several questions. Do you notice any patterns? The digits that repeat will become the numerator. The number of digits that repeat will become the number of 9s in the denominator. For example, 0.6 repeating has one digit that repeats. Therefore, the 6 becomes the numerator. And since only one digit repeats, we use only 1 9 for the denominator, 6 over 9. That can then be simplified to 2/3. The two digits that repeat, 1, 5, become the numerator. Since two digits repeat, use 2 9s for the denominator, so 15 over 99, which simplifies to 5 over 33. This approach yields the same results as we found earlier, just more quickly. Here's a very interesting example. This shows that 0.999999 repeating is actually equal to 1. If x is 0.999 repeating, that means that 10x is 9.999, and so on. If you then subtract those equations, the 0.999 goes away, leaving x equals 1. That's very interesting. In the case of 0.83333 repeating, the 3's repeat, but the leading 8 does not. The same method can be used with one extra step. Begin as before, creating equations for x and 100x, and subtract these equations. The only problem is that the number on the right, 82.47, is not an integer. So we need to multiply both sides by 100 to make it an integer. The subsequent simplification to 5/6 requires repeated division of common factors. There is another approach that makes the simplification easier, and both work. In cases when there are one or more non-repeating integers preceding repeating integers, there are two approaches to solving the problem. Here are some examples. So you can see that we have 1.5656 repeating, 7.4949 repeating, where only the 49 repeats, not the 7. And over here, 145, 145, this part repeats, but not this initial 5. The first method is to use the same approach we've been using. The correct answer will be found, but as we will see, simplifying the fraction will sometimes take multiple steps. There is a quicker, simpler, alternative approach. We'll show both in the following slides. In the case of 0.83333 repeating, the 3's repeat, but the leading 8 does not. We can solve using the same approach we've been using, but some complexity results in the last steps. First, we write equations for x and 100x, but we also create an equation for 10x. That moves the 8 to the left of the decimal point where it can subtract from 83 and yield an integer, 75. So we end up with 75 over 90, which is 5 over 6. This process makes the repeating decimal disappear and simplifies the resulting fraction easier. Here's another way. Write the equations for x and 10x. Subtract the equations. The result is a fraction with a non-integer numerator. Multiply the numerator and denominator by the same power of 10 needed to make the numerator an integer. In this case, 7.5 becomes an integer. If you multiply it by 10, it becomes 75. So you're just going to multiply top and bottom by 10 and then simplify, which in this case takes a couple steps. Here's a second example. Let x equal 0.736666 repeating. For the first equation, multiply by 1,000 to get the first repeating digit, the 6, to the left of the decimal point. For the second equation, multiply by 100 to get the non-repeating integers to the left of the decimal point. Then subtract, and you will get 663 over 900. This subtraction here gets rid of the repeating portion. Then create a fraction and simplify. Here's another example using both methods. X equals 0.91666, where 6 is the repeating decimal. So we're going to create 100x, and then we're just going to subtract x, which gives us a fraction that has a decimal in the numerator. So to get rid of that, we multiply top and bottom by 100, so that we get 9,075 over 9,900, then simplify to 11 over 12. Over here, we create two equations, 1,000x, and then we subtract 100x, and we get 900x equals 825, which they're both integers. So then you just create the fraction and simplify. The same answer is obtained, so either method works.